Hi guys, Assalamualaikum. Welcome back to another virtual lecture. In today's video, we're going to learn about hypothesis testing. So what is hypothesis testing? Let's take a look at what hypothesis means first. Okay, so a hypothesis is a statement or a generalization or even an assumption that we make about a population. Okay, so these statements can be anything. It can be differences between groups, it can be relationships between variables, or it can even be changes that occur. Let me give you an example. Suppose I make a statement. All of the students taking statistics this semester have a CGPA of 3.0 and above. So I want to test that hypothesis. Is it true or not? However, we know that it's quite difficult for me to get information from everyone, right? Because, well, simply I'm not teaching all of the students in statistics. But I do, however, am teaching you guys. So you are technically a sample of the population of students taking statistics. So instead of focusing on mu, which I couldn't get because I can't get everyone's information, I can get X bar. So that means I can ask each and every one of you your CGPAs and get the average of it, okay? So that's basically what hypothesis testing is. I want to test my claim on that population, but because I cannot get access to the entire population, I just take a sample from the population and conduct my study on that sample, okay? So the process of generalizing whatever information I get from my sample and to generalize it back to the population is called the hypothesis testing. Okay, so hypothesis testing is basically a procedure based on sample evidence and probability theory to determine whether whatever hypothesis that I made before was reasonable or not. Let's take a look at how to conduct a hypothesis testing. As mentioned before, it is a procedure based on sample evidence. Therefore, there would be steps to take in order for us to conduct a hypothesis testing. There are generally 6 basic steps to do so. Okay, so let's look at the step one by one. Step number 1. Before we can conduct a hypothesis testing, what we need to do is to come up with a hypothesis first. That is, we have to have a statement. Otherwise, there's nothing to be tested, right? Okay, so there are 2 types of statements that we need to make. One is called the null hypothesis. Okay, very rarely we write it in complete sentences. So normally we write it this way, H null. Okay, then the next statement that we make is called the alternate hypothesis, H1. So what's a null hypothesis and what's an alternate hypothesis? Now remember earlier when I gave you an example, I said that the entire population of statistics students have a CGPA of 3.0 and above. See, I'm making a generalization towards the population. But is it true or not? I don't know, but I assume it's to be true. So that's basically the null hypothesis. It's a statement that we make about the population that we assume to be true. But what if, after conducting the hypothesis testing, based on my sample, I don't have enough evidence to support the hypothesis I made earlier? Therefore, we have to come up with an alternative statement, right? So that is where the alternate hypothesis comes in. Okay, so the alternate hypothesis is basically the statement that we accept if sample data does not provide evidence to support the null. In other words, if the sample data provide evidence that the null is false. So at the end of the hypothesis testing, we have to accept either one of these statements. If we have evidence to support the null, so we do not reject the null. But if we don't have evidence to support the null, we have to reject the null and accept the alternate hypothesis. So how do we write this hypothesis? Okay, I will show you in a more detailed example later, but for now, you need to remember that whenever we want to write the null hypothesis, we always put the equality signs in it. So what are the equality signs? There are 3, okay? So it's not just equals to. Besides equals to, another equality sign is greater than equals to and less than equals to. Okay, remember, these 3 equality signs are always a part of the null hypothesis. Now, alternatively, the inequality signs are always a part of the alternate hypothesis. These are basically signs which are opposite of the equality signs. What is the opposite of equals to? Not equals to. What is the opposite of greater than equals to? Less than. What is the opposite of less than equals to? Greater than. Okay, so at every one time we write a hypothesis, there's only going to be one, okay? There's only going to be one null hypothesis. Then there will be also only one alternate hypothesis. Okay, we're not going to write all of these three in one sentence, okay? Take note. Once we have our hypotheses in place, step number 2 is to select a level of significance, or alpha. What is alpha? It is the level of risk that we take in rejecting a true null hypothesis. Let me try to explain further. When we want to test a hypothesis, there's the possibility of making two types of errors. Now let's look at this table to understand more. Okay, now say we make a hypothesis, and then from our sample we find evidence to support that hypothesis. So in a way, we find that our hypothesis is true. So by right, if our null hypothesis is true, this should be our correct decision, not rejecting it, right? However, there might be the small instances that we actually reject a true null. This is the first type of error that we can make, which is called the type 1 error. Or here, type 1 error is rejecting a true null hypothesis. Okay, now let's look at another instance. Let's say our null hypothesis is actually false. Okay, so by right, if our null hypothesis is false, this should be our correct decision, to reject it. However, we might make a mistake of actually accepting or not rejecting a false null. This is called the type 2 error. Okay, so let me repeat. Type 1 error is rejecting a true null. Type 2 error is accepting a false null. Now, where does the alpha or level of significance come into place? The probability of making a type 1 error. Now that is the level of significance, or alpha. Whereas the probability of making a type 2 error is known as beta. The third step in conducting a hypothesis testing is to calculate the test statistic. Okay, so what is test statistic? Test statistic is basically a value that we calculate from our sample. Okay, this test statistic is used to determine whether or not to reject our null hypothesis. Okay, so previously we've learned two distributions. If our sample size is large, and we know the sigma, we use the Z distribution, right? And if our sample size is also large, and even in the case of where we do not know what the sigma is, we still use the Z distribution. And we also learned that if our sample size is small, and when we do not know the sigma, we use the T distribution. Now guys, these Z and T distributions, these are our test statistic. Okay, so basically our test statistic would either follow the Z distribution or the T distribution depending on the circumstances. Step number 4 in hypothesis testing is to formulate the decision rule. Now this decision rule is basically a condition that tells us whether to reject the null hypothesis or to not reject the null hypothesis. So how do we write this decision rule? Well, to understand it is to know these two areas. The first area is called the rejection area, or rejection region, which is a range of values that rejects the null hypothesis. Okay, so basically if you reject the null hypothesis, what it means is we support or we accept the alternate hypothesis. The other region is the acceptance region, or acceptance area, in which it is a range of values that support the null hypothesis. Both the rejection and acceptance areas are separated by what we call the critical value. Okay, so this critical value is basically a value that we compare against the test statistic that we calculated earlier in step 3. Okay, in other words, if our test statistic follows the Z distribution, our critical value will also follow the Z distribution. If our test statistic follows the T distribution, our critical value will also be the T distribution. Remember, we need to compare like with like. Test statistic is something that we calculate, whereas the critical value is just something that we look up at either the Z table or the T table, depending on what the distribution our test statistic follows. So once we've calculated our test statistic and then we compare it against the critical value, we come to the step 5 of hypothesis testing, which is to make a decision. Okay? The decision is either to reject the null hypothesis or to not reject the null hypothesis. And finally, step 6 is to interpret our results. Okay guys, now let's recap all of the 6 steps of hypothesis testing with an example. Okay, so now let's say we are conducting a one-sample hypothesis test on the population mean. Okay, so our statement is the mean income of women is less than or equals to $65,000 a year. Okay, so let's begin. Step 1. Okay, we need to do what? We need to write our hypothesis. Okay, so let me repeat again what was my hypothesis just now. I'm saying that the average income of women is less than or equals to $65,000 a year. So how do you write that? Okay, the null hypothesis is, okay, after you write the H null, we put a colon. Okay, so we're saying the mean income of women is less than or equals to $65,000 a year. Now remember, the hypothesis is always a statement that we make regarding the population. Therefore, we have to write the population mean here. Okay, do not write anything else. Many students make the mistake of writing X bar here. Okay, so don't do that. You must always write the population parameter. In this case, since we're testing the mean, so we have to write the population mean. Okay, so now let's go back to the statement. The average income of women is less than or equals to $65,000 a year. Less than or equals to $65,000 a year. So this is our null hypothesis. Okay, so now after we write the null hypothesis, we need to write down the alternate. Okay, the alternate is basically the opposite. Just in case we want to reject the null, so we need to accept the alternative. Okay, so the alternate is, again, now this time you put H1, or some textbook put it as HA for alternate, but we want to be consistent with your textbook. Okay, so we put it as H1. Again, a colon here, a mu. Okay, so now the sign that we write here is the opposite of what we wrote earlier. So earlier we wrote less than equals to. So the opposite of this is greater than. What? The same value here. All right? Okay? So I hope this is clear. Okay, again, our statement just now was the average income of all the women is less than or equals to $65,000 a year. This is how we write the null hypothesis. And the alternate is, we're saying the average income of women is more than or greater than $65,000 a year. Now, this is called a one-tailed test. Why? Because the sign of the alternate hypothesis shows a particular direction. Okay, it shows one direction. Okay, so in other words, we're saying that this is a one-tailed test. Okay, so this is step number 1. Now, step number 2 is to find or to write down our level of significance. Now, normally the alpha is always going to be given to you in the exam. So let's say alpha is given to you as 5%. Okay, so alpha is given to you 5%. Okay, so now step number 3 is to calculate our test statistic. Calculate test statistic. Now, for the purpose of this illustration, we can skip step number 3 because not enough information is given. But we do know that test statistic is either following a Z distribution or a T distribution, depending on the circumstance. Okay, so if we have a large sample size and we know sigma, we can use Z as a test statistic. Okay, if we have a large sample size but we don't know the sigma, we can also still use the Z distribution, but then we substitute the sigma with S. And if we have a small sample size and we don't know the sigma, we use the T distribution. Okay, so moving on, now we need to do step number 4, which is to formulate the decision rule, right? So we have to formulate or to write down what our decision rule is. Okay, now remember, what is the decision rule? The decision rule is a condition that we write and to guide us whether to reject the null or to not reject the null. Okay, so in this case, we need to do some sketching. Okay, so this is the only time, I guess, that we're going to be sketching anything. So what are we going to sketch? We sketch our regular normal distribution. Okay, so anyway, this is basically our X scale, right? Okay. Now we know from the question that the average here is $65,000. Let's write it down, 65,000, okay, which is our X scale. Okay, now since we're going to formulate the decision rule, we know that we need to find our critical value, right? Okay, let's write it down here as well. Okay, remember what is critical value? Critical value is that value that separates the acceptance area and the rejection area. Now, how do we want to find, or how can we find the critical value? We need to know two things, okay? Number one, we need to know our alpha, or our level of significance, okay? And secondly, we need to know whether our test is a one-tailed test or a two-tailed test. Okay, what does that mean? A one-tailed test means we only have one rejection area. Two-tailed test means we have two rejection areas, okay? So now how do we know what our tail is? Okay, because normally alpha here is given, right? So not a problem. The first part is not a problem, we know. So how do we know whether our test is a one-tailed test or a two-tailed test? It's very simple. What we need to do is we need to look at the sign of our alternate hypothesis here. If the sign of the alternate hypothesis is showing one particular direction, okay, so here it shows one direction, right? Greater than. Okay, so that means we have a one-tailed test. Okay, so in this case, where shall our tail be? To the right or to the left? It's very simple. Again, look here. Okay, I'm going to do it very slowly. Okay, we are hypothesizing that the alternate is an average of greater than, more than 65,000. So we know that 65,000 is here, right? So where is the area of more than 65,000? Yeah, here. Okay, so this would be our rejection area. Okay, let's write it down. This is our rejection area. In other words, if our test statistic falls here, what we need to do is we need to reject the null. Okay? But if our test statistic falls here in the acceptance area, what we need to do is we need to not reject, or do not reject, the null hypothesis. All right? So now, since we know the alpha is 5%, that's basically this area, okay? So the area here for the rejection area is 5%. So how much, or what is this percentage? Simple, it's 95%. So from here onwards, this is 95%. Why? Because 95% plus 5% is 100%, which is the total area under the curve. Right. Okay, we haven't still found the critical value yet, guys. Okay, so we need to imagine, okay, say we were to standardize all of our X bar values. So 65,000, when we standardize it, it becomes 0, right? Remember anything in the center here? When we standardize it, it becomes 0. Now this value that we don't know, okay, now this is basically our Z value, right? Okay, so we've learned before, right? Can we find the Z value given this situation? Yes, we know. Okay, it's here. See, I'm going to show you again in case you've forgotten. All right, so this area is 95%. So we know here is 50% or 0.5. So how much is this area? Okay, we should get another colored pen. Okay, so this area is basically what? 45%, 0.45. So now you take your normal table and try to find this dotted blue area, and then we can find the corresponding Z value. So here I have the normal table. Now this 45% is the probability, right? So you need to look inside here. Find the closest value to 0.45. Okay, so here we discover there are two values very close or closest to 0.45, and they are 0.4495 and 0.4505. Now in the event that we've got two values which are equally distant from the value that we want, we take the bigger one. Okay, so in this case 0.4505, the corresponding Z value is 1.6. Okay, let me show you 1.6, which is here, and you go up 5. So that is basically our Z value. Okay, so here is 0, so here's basically 1.65. Okay, so what is this 1.65? Guys, this is our critical value. Okay, so now, since we know what our critical value is, we can start to write down our rejection rule. Okay, rejection rule is another name for decision rule. Okay, so how do we write down the rejection rule or the decision rule? We say that reject the null if what? So we're basically describing this area. I already mentioned to you just now, we are going to reject the null if our test statistic falls here, right? So that's basically what we're going to write. We reject the null if the test statistic is greater, right? Greater than, what is the critical value? 1.65. So that's basically how we write the decision rule. So what is this test statistic? Well, since we skipped that part because there's no information, it can either be Z or T. So later on, we can put here either Z or T. Now, once we've formulated the decision rule or rejection rule, okay, what we do is we make the fifth step, step number 5, which is to make a decision. Okay, what decision are we going to make? So we either reject the null or do not reject the null. So how can we make the decision? What we need to do, guys, is we need to compare between our test statistic and whether it falls in the acceptance area or the rejection area. So as we mentioned from here just now, we know our critical value is 1.65. So we just compare. What is our test statistic? Where does it fall? If our test statistic falls here, let's say somewhere here, then we say since the test statistic lies or falls in the rejection, oh, terrible writing, rejection area. So what do? We reject the null hypothesis. Okay, well, actually, there's a longer sentence. You say that since the test statistic falls or lies in the rejection area, we don't have sufficient evidence from the sample to support our null hypothesis. Therefore, we reject the null hypothesis. Okay, so you can read more of that in the textbook or the e-books. Okay, so here I just want to be short. Okay, however, okay, this is one option. Option 1. However, let's say if our test statistic falls somewhere here, it could be here or here, anywhere, as long as it falls in the acceptance area. So we can say, okay, this is the alternative, or it's not that we're making both the decision is choose. Okay, since the test statistic falls or lies in the acceptance area, we do not reject the null hypothesis. Okay, so it's either or. So it depends. It depends on where our test statistic falls here. Okay, that's it. And of course, step number 6. Okay, we interpret. Okay, interpret our result. Okay, so how do we interpret the result? And normally when we interpret, we have to go back to the context of the question. Okay, so in our case just now here, okay, let's go back. We're saying that our null hypothesis is the average income of women is less than or equals to $65,000. Okay, so it depends. If we reject the null, okay, if we reject the null, that means we take the alternate, right? So how do we interpret? We can say that based on our evidence from the sample collected, we can conclude that the average income of women is greater than $65,000. That's how we interpret. But let's say we decide to do not reject the null because of insufficient evidence, okay, or sufficient evidence to be exact. So if we say do not reject the null, let's go back here. So if we don't reject it, we take it lah. Right, so how do we interpret? We can say that we have sufficient evidence to suggest that the average income of women is indeed, in fact, less than or equals to $65,000. Okay, so now let's do another example, but this time I'm going to show you how to conduct a test, which is a two-tailed test. Okay, so again, as usual, step 1, we want to write down our hypothesis. Okay, so let's begin. H null, colon. Okay, so same story now, but then of course we have to tweak and change it a little bit. So just now our example was the average income of women is less than or equals to $65,000 a year, right? But now our hypothesis is slightly changed. I'm going to say that the average income of women is $65,000 a year. So how do you write that? The average income of women, remember mu, why mu? The hypothesis is always about the population, okay? So you put mu here. The average income of women is 65,000. So is means equals to, okay? $65,000 a year. So how do we write the alternate? Remember, the alternate is always the opposite of what we wrote here. Okay, so what's the opposite of equals to? Not equals to $65,000 a year. Okay, so this is basically how we write the hypothesis. Done. Okay, now step 2. Let's say the alpha is similar to before, which is 0.05. So 5% alpha. Okay. And as always, here step 3 is we need to calculate the test statistic, but just like before, not enough information was given, so we can just skip this first. So remember, the test statistic can either be a Z value or a T value depending on the circumstance of the question. Okay, and then step number 4, okay, this is the part where we sketch something. We need to construct the decision rule. Okay, construct or make the decision rule or the rejection rule. Okay, so how do we do that? Okay, can you see? All right, so here's our normal distribution. This is all of our X bar values. So we know from the question just now, okay, mu, or we hypothesize the mu to be 65,000. Okay, so it's here. This is our average, 65,000. Okay, so now remember, the thing we need to do is to find out what our decision rule is. We need to know what is our critical value. Okay, how to find the critical value? Like before, we need to know two things, right? The first thing we need to know is what is our alpha, which is known. It's given to us, 5%. And we need to know whether our our test, is it a one-tailed or a two-tailed test. Now, this example is a two-tailed test because if you look at the hypothesis that we wrote, okay, look at the sign of the alternate hypothesis. It's not showing a particular direction. Okay, in fact, because when you say something is not equals to, it could either be more than 65,000 or less than, right? So there's basically, we're not sure what the direction is. Therefore, it is a two-tailed test. So what that means is, if it's a two-tailed test, we will have two rejection area. So this would be our first rejection region. So you know that the rejection region means we reject the null. And here would be our next rejection area. So here's another one where we put the rejection or reject the null. And in the center here would be our acceptance area. Okay, acceptance area meaning we do not. Okay, do not what? Do not reject the null hypothesis. Okay, so from here to here is 95% or 0.95. Okay, how do we know that? Because the level of significance or significance level is 5%. So just like before, our rejection area or the total rejection area would have to be 5%. But because we've got two tails here, therefore we need to divide this 5% into 2. So here would be alpha is 0.025. Here alpha is 0.025. Okay, so of course what's the balance is 95% because total area must be equals to 1 or 100%. Okay, so can you see the difference here? All right, so here we've got two tails, therefore we've got two rejection areas. Now just like before, because we need to know what our critical value, in this case we need to know what our critical values are. There's two. Okay, so we need to know what is this. And okay, before that, here is our corresponding Z value. So whenever we standardize all of our X values, we get Z, right? So standardizing the mean would give us 0. Standardizing this value would give us Z, positive Z. And standardizing this value would give us a minus Z. So how can we find the critical value here? Now, this can only be applied for a two-tailed test, okay? This is actually a shortcut. We can utilize what we've learned in the confidence interval topic here. Remember I told you to memorize what are the Z values associated with a particular confidence level? Right, so if the confidence level is 95%, remember what was the corresponding Z values? Yeah, 1.96. So here can be 1.96 and here is minus 1.96. Remember, you can only use this shortcut if it's a two-tailed test. Okay, right, so 1.96. Right, so here would be our critical values. So how do we write the rejection rule? The rejection rule, since we have two rejection areas, therefore we have two rejection rules lah, okay? So we reject the null if the test statistic is greater than 1.96, see? We reject the null if the test statistic falls here, if it's more than 1.96, meaning as long as it falls all of this area. These are all of the rejection values, okay? Or we reject the null if the test statistic is less than minus 1.96 here. Okay? All right. Then step number 5. Can you see? We make a decision. Okay? Which is, it depends. Okay? We compare where our test statistic is in relation to our critical value. If the test statistic falls here, any part here or here, so we can say, since the test statistic falls in the rejection area, we reject the null hypothesis. But if your test statistic falls somewhere in the acceptance area, we say that since the test statistic falls in the acceptance area, we do not reject the null hypothesis. Okay. Then step number 6, we interpret. Again, interpreting is basically depending on the question. Here, so look at the question here again. If, let's say, we reject the null, okay, so if we reject the null, we are actually accepting the alternate. So we say that we can conclude based on our sample evidence that the average income of women is not equals to $65,000 a year. But if we say do not reject the null and we choose this one, so how do we interpret? We can say that based on based on the evidence collected from our sample, we have sufficient evidence to suggest that the average income of women is in fact $65,000. Okay, right.